Okay, welcome to the integration by parts and definite integrals. Looking at example 9, we're going to integrate from our lower bound of 0 to upper bound 1 of x times the inverse sine of x squared dx. So grabbing your acronym, we have an inverse trig function, that's for I. Let's put down our integration by parts formula. Our u will be the inverse sine of x squared. Our dv will be x dx. The derivative of the inverse sine of x squared, if you look at your paper or derivative sheet, it has it on there. This is going to be, I think they have a u here. It'll be du over the square root of 1 minus u squared. So since my u is x squared, du is 2x. X squared squared is x to the fourth. Integrating x dx is x squared over 2, or 1 half x squared. We'll make our substitutions. Remember our pattern is u times the v. Multiply those two minus the integral of our v times the du. And there it is. We have some simplifying in this integral here. For example, the 2 and the 2 will cancel. X squared and x gives us x to the third on the top. And, compared to the bottom, there's an x to the fourth, 1 power bigger inside my square root. With an x cubed on the top, that's a perfect u sub situation. So we'll let 1 minus x to the fourth be my u. The derivative of that is a negative 4x to the third, which is that x to the third on the top. Scalar factor is okay because we can always divide over the negative 4 and make that negative 1/4 du equals x cubed dx, which we have. So over to the side, I'm just going to do my u sub of this red integral right here. Okay, so 1 over the square root of u, change that. Let's call that u to the negative 1/2. Use the power rule, add 1 makes it a positive 1/2. Divide by 1/2, which means, okay, we're going to factor that out, multiply it to our negative 1/4. So dividing by a half is the same as multiplying by its reciprocal 2. We multiply it to the negative 1/4, makes it a negative 1/2. Put your 1 minus x to the fourth back inside the square root. And now we'll replace all this red integral here with a negative 1/2 times the square root of 1 minus x to the fourth. All right. There's my substitution. Let's distribute. We'll fix up the signs here. Plus 1/2. Now we'll integrate. We'll evaluate everything. We'll put in 1s for all the x locations. There they all are. We'll put 0 into all the x locations. So the inverse of sine of 1, think of your unit circle. That would be pi over 2. Where is your y coordinate of 1? That's at the top of your unit circle at 0, 1. So that's pi over 2 times a half plus 1/2 times 0. So that's gone right here. So that's these two terms right there. Inverse sine of 0 times a half times a 0, all of that is 0. We don't even have to worry about evaluating the inverse sine of 0 because we multiplied by 0. 1 minus 0 is 1, square root of 1 is 1, so plus 1/2 is left over in my bracket, so minus the 1/2. Multiply those two together, pi force minus 2 is our answer, or if they want a decimal response, that's my approximation. Now, sometimes making a substitution before your integration by parts can simplify your work. So for example, this could be a tabular integration. It could be a mess. But again, the clue is as follows. If you see derivative powers here differing by 1, we could make this a lot easier by doing, in this case, we're going to call it a w sub because I don't want you to get it confused with these u's. What I'm going to do is I'm going to let and get rid of this x squared in my exponent position on my e. That's going to be messy if I tried to do my integration by parts. So let's make this x squared be my w. We're okay if there's a negative there. That doesn't bother me. The x squared bothers me. All right, the derivative of x squared is 2x dx. So what I need to do is with this x cubed, I need to factor an x over here with my d. So break it apart, x squared, move one x over with the dx, and now divide over the 2 to 1/2 dw is my x dx, so there's where my dw is going to go. We'll put 1/2 in the front, and now this will be w times e to the negative w. Now that's much easier to take care of my integration by parts. So now using this, we're going to let our algebra, our w, dru, our e to the negative w power, dw is my dv. The derivative of w is just dw. Nice and easy. Integrating e to the negative w is just e to the negative w, but again, remember, you're going to have to take the derivative of the negative w, which is just negative, and multiply it or divide it, especially when you got -1, doesn't matter whether it's multiply or divide. And now we can rewrite this as 1/2 brackets, there's my u, times my v, minus the integral of my v times my du. So let's clean up some signs here. Minus a negative makes that a plus. Oh, how convenient. We've already integrated e to the negative w power. That's this, so we'll put negative e to the negative w right there. Substitute that in. Put in our plus c after everything. And then let's see, what can we do to clean this up here? Oh, I have a factor of negative e to the negative w in both spots, so let's factor that out front with the 1/2. So negative 1/2 e to the negative w, and then you're left with a w plus, since all this factored out front, there's a 1. And now, we're almost done. We're not done yet. Remember, what was my w? X squared. So put the x squared back for this w and for this w, and now you're all done. Example 11, integrating sine of x, cosine of x dx. We're going to do this a number of different ways. We're going to look at it as integration by parts first. So my u, again, pick the easiest u, which would be sine of x. Cosine x dx is going to be my dv, because when you take the derivative of the sine, it's cosine, no sine issues. And when you integrate cosine of x dx, you get to sine of x. So that's why I did choose cosine here, because that would introduce negative signs to my other two answers down below. So to complete this by integration by parts, you have sine of x, those two multiply together, minus sine of x times cosine. Oh, wait a minute, I just started with that. So this is one of those circle backs. Add this over to here, that gives you 2 integral sine of x cosine dx equals sine squared of x. Divide over the 2, and you get 1/2 sine squared of x plus your c. All right, now, don't get me wrong. We could do this by u substitution. Let's do that by u sub. We could let sine of x be u, du cosine x. We'll just copy this part right here. Make our substitution. We're integrating u, du becomes u squared over 2. Put your sine of x back in for u. We get 1/2 sine squared x plus c. It's the same answer if you did integration by parts or u sub, which is cool. All right, now, however, throw another curveball at you. What if we wanted cosine of x to be your u? Now, as I explained up here why I chose sine of x first, because now your du has negative signs, and we've got to keep track of negatives. And that would have been a negative down here too. We'd have 2 sets of negatives. But if I did u substitution here, this would be a negative, because remember, we got to divide over the negative. U du, which is now negative u squared over 2 plus c when you integrate it, Now we put cosine of x back in for u, so it's cosine squared x multiplied by negative 1/2 plus c. A completely different answer, which is okay. I'll show you why these are all considered to be correct. Next, another trick. If you look at your trig identity, sine of x times cosine of x is usually a good indicator that you want to have a double angle identity. So if I multiply 2 to sine of x cosine of x and then factor out 1/2, this right here is your double angle identity for sine of 2x. So now my u sub would just be 2x, and du would be 2 dx, and I divide over the half. So this becomes 1/2 times 1/2, because this gets multiplied over to here, of sine of u du. Well, okay, integrate sine of x is cosine x dx, so if you put a u there, it's just cosine u. 1/2 times 1/2 is 1/4. If I integrate, where is it? Where's my integration of sine? Oh, integration of sine is a negative. My apologies. I was doing my derivative here. I should have went the other way. So integrating sine is a negative cosine. Now bring back your 2x back inside for u, and there is my final answer. So this one has 3. The blue and the purple were the same, the red and the black. So if I entered all of them into my calculator to graph them, notice I didn't put the plus c's on. When you do your trig graph, you'd have to do zoom 7 to get this graph. You'll notice here's the blue curve. The black curve is my negative 1/4 cosine of 2x. And there's my red curve, negative 1/2 cosine squared of x. They're all similar to each other. The only thing that's different is the plus c, because we don't know what the constant is that you're adding. So I could add to move it up over the blue. I could add something to the red to make it on top of the blue. So they're all the same representations, except for what this unknown constant is going to be that you are going to add to it. All right, kind of an interesting problem here, looking at 3 different ways to, or actually 4 different ways to integrate to get 3 different answers. But if you compare the graph, it all comes out to be the same.